this is your first time, okay, yeah, so it's usually like 50-50 split. So the universe is still in function. I'm just gonna go through some simple things to start off with before we get into the talk. So if you parked in the garage downstairs, please ask Justin on the way out the front desk for validation. As long as you parked after 6 p.m. and you head out before 10 p.m., you'll be good. I think it's $8. And then this group usually meets on the first Tuesday of the month. This month we had to do Thursday, but usually it's the first Tuesday. So just keep that in mind if you're new. And there's plenty of AI groups in Austin now. Our group is more focused on research, papers, breakthroughs that come out, and also applications of those things. And this is also the oldest group in Austin and the largest group in Austin. So we have a few thousand members online. We get a pretty good crowd to show up every month. And it's been around since 2016. I've had the pleasure of being involved since 2020. And it's a very open, thank you. It's a very, that was a pandemic, we were, so this is a very open discussion. This isn't like a one-way thing, so please raise your hand, ask questions. There's gonna be two ways to do that, you'll see in a second. Please ask questions, please provide insight. If you think you know something that one of us up here doesn't, or if you wanna add some other value, that's totally allowed, that's encouraged. So just raise your hand. And if you do wanna ask questions, there's two ways. The old-fashioned way, raise your hand and you'll get called. The other way is go on Slido. You can just scan that QR code and you'll be good. You don't need to make an account. Otherwise, if the QR code is not working for you from the back, just use that number. So just go to slido.com. It's 393-7794. So 393-7794. I'll give you a minute. Okay. And if anyone just wants to like send a little test message, test, then I'll be able to confirm. Yeah, it's working. Okay, thank you. I got 5 y'all. And it's anonymous, so if you feel more comfortable asking through that channel, please do. But yeah, with no further ado, let's go on this presentation. So Yinxi here of Databricks. She's a data scientist at Databricks. She's been there for 3 years, and she's actually a long timer at Austin Deep Learning. So she came back after a little hiatus, but she was here since 2019, and she's really wanting to give this talk because DBRX is about using the right tooling for building your own LLM with governance and control. And so DBRX is a living case study of how to do that. And who better than someone from Databricks themselves to come and give that talk. So please give a round of applause for Yinxi.
Thank you. All right. I'll do a quick introduction. Hi, everybody. My name is Yinxi Zhang. As Raksha introduced, I've been member with Deep Learning, so I've seen a few familiar faces, and miss you guys, and glad to come back and give this talk. We have a few Databricks folks here as well to help answer questions. So this talk is trying to give a quick introduction to DBRX, which is in-house LLM tool Databricks built from scratch. And we will be focusing on what kind of tooling we used, and also a few benchmark results. And we'll show you guys how to use, where can you access the DBRX model in the end. All right. So DBRX is Databricks' very own open source LLM model. From the latest release, we have released 2 versions of DBRX. One is the base model, which is doing task completion, and the other is the instruct model, is fine-tuned for chat tasks, designed to answer questions, to follow instructions, and that is built, the instruct version is built on top of the base version. So this is a quick demo of, I think this was a GIF and it wasn't downloading well using PDF. But the point here is we actually have a panel-to-panel comparison using DBRX and Llama 2, because it was published before Llama 3 become available. So we did the comparison between Llama 2, and you can see the token generation token generation speed is faster than Llama 2, and you can also compare the response from the 2 sides. This was sorry that it wasn't rendering very well, and In terms of performance, at the published time, DBRX actually outperforms the open source model like Llama 2, Mistral, and Grok. We benchmarked against a few different data sets, like a few different tasks, like the multi-language language understanding using multi-choices and results, and also programming tasks as well as math tasks. So I'm going to gloss over a few of the slides just to focus on some of the key takeaways. And this one is trying to compare the DBRX against the GPT 3.5. DBRX basically outperforms GPT 3.5 as well. So this is open source model compared with a closed model with the different tasks. You can see the benchmark results. Right. At the same time, like Gemini is moving super fast. Like within the past months, we have a lot of model being published, and every day there's new things coming out. And the key idea is not to have the best model of the world and keep using that. The key idea is to being able to keep up with the high top tier models and adapt that to your own data. So we can see that the model performance just keep evolving, and it will do that continuously. This is the results from Meta's Llama 3 blog, and you can see that Llama 3 actually have really good performance as well. So what we want to share with the audience and everyone here is that how do we build this LLM from scratch, and how you can do that using your own customized data, so you can have full control of the model and using open source tool to build it, and also have proper governance over the data you use. All right, for the next section, we will talk a little bit more about how the architecture of DBRX, what kind of transformer architecture we use, and how we build it. So DBRX is transformer-based decoder-only LLM. So if you guys are familiar with the LLM concept, the transformer architecture have different types. The translation-specific type of LLMs are usually encoder-decoder type of models, which it translate one sentences to another sentences, and then we have encoder type of model for classification type tasks, and BERT is a very typical and most common example of that. Generative models like GPT, Llama 3, those are all decoder-only models for generative tasks. And DBRX is also decoder-only LLMs, and it is created entirely from scratch using Databricks toolings and also using open source data. So it was trained on data publicly available from online data source. We did not use customer data to train the DBRX. If you interact with DBRX on our platform, we will not train on your data either. And from the benchmark results, we have estimated that the data we use for the training process is at least 30% token to token more efficient. Token have 30% better token to token efficiency when comparing with the data we trained for the MPT models. For folks who are not familiar with MPT models, MPT are the first version of open source model Mosaic AI published, and Databricks actually acquired Mosaic AI 2 years ago or 1 year ago. So now we become one company, and we're leveraging the Mosaic AI's tool team and experience and the tools to build the DBRX model. So in terms of what kind of resource we used, the model was pre-trained on over 3,000 NVIDIA H100 GPUs that include both pre-training, post-training evaluation, as well as final refinement. And the whole training process take over 3 months. Should I pause here for questions?
You're always welcome to raise your hand, but does anyone have any questions right now?
Yeah.
Yes.
So when talking about curriculum learning, how do you change the mixture? What type of data do you start with, and as the training goes on, what type of data are you going for as it's more mature, I guess?
Yeah, that's
Is it
a
okay
great
if I
question.
repeat the question? So he asked, when you're doing curriculum learning, how are you modifying the mixture of the data as you continue training?
Yeah, we have Zhang here, and he works like closely with the model training process, and I'll direct that to Zhang.
I think without saying very specifically what happened here, generally you're going to train for 70, 80% of the way through on general web data. You're building a base of language capability, and you just want as much and most varied data as you can. Pre-training kicks in the last, I don't know, fifth of the training, and there you want to get more targeted. So you're pre-training on data sets that are more relevant to the skills you want to elicit. Could be code, could be math papers, for example. And yeah, that mix shifts not even once. You can shift it multiple times over the course of training, but it happens mostly at the end. Maybe that's a general observation that's definitely true. Yeah.
Yeah.
How much of that data that was trained on throughout any of the process, how much of that was from general accessible web data that has already existed, either obtained through some sources that it was there, from human annotators that you added, but how much of it was bootstrapped using LLMs themselves?
Good question. Okay, I think it's fair to say, sorry, the question was how much of this 12 trillion tokens was general web data, how much was maybe synthetic data, how much was created by humans? That I think I'm not allowed to say, but I can say in very general terms, it's mostly open web data. And it wasn't, I think we said this, it was 3 trillion tokens run 4 times. And even that's a lot of data. And yeah, you're not going to be able to synthesize or annotate 3 trillion tokens. It's mostly web data. Yeah. The data mix is maybe less surprising than you'd imagine. I'll say that. So it was trained for 12 trillion tokens, but that was the same 3 trillion tokens repeated for 4 epochs, which you can kind of get away with. Probably not a lot more than that. How about this? I'll tell you in that vein, the best data sets I think we would use if we did this today, or you were doing this today. So yeah, you're gonna need a big chunk of web data. You're obviously gonna look at common crawl derivatives like RepPajama, in the past C4, Dolma. The one I like a lot right now is FineWeb from Hugging Face. That's Hugging Face's parsing of common crawl dumps with their library data trove. At least internally, that did a little bit better than alternatives. And that's going to be the bulk of your training set. The rest is a little bit secret sauce. I'm being a little cagey because this is actually where, if there's any secret sauce, that's where it is, the data mix. It's not so much the architecture or the training. But again, probably no big surprises there. Key data sets we like, open web math, for example. Great data set. I think what Jonathan, this is our research leader, I think what this meant was to get to the same level of accuracy, you would have to train 30% less.
And that is only comparing against MPT, not comparing against other models. Yeah, go ahead.
So I'm really curious to hear your speculation on this. If you were to instead have a method that would find you like the best quality data in the web scrape data, I think you said 30% is probably how much you need, but what would you speculate would be the actual data need? If you were to just find the peak data in those data sets.
So the question is, how much high quality data do you need? Like how much of the mix is high quality data? Oh, I see. So if we do training on, let's say, web slop, we call it web slop internally, and train a bunch on that and then finish with this high quality data, why bother with the rest? Yeah, it turns out that doesn't quite work to just ignore the rest. I don't have a great explanation for that other than there's just a lot for the language model to learn. It needs a lot of training, and if you're gonna train that long without overfitting, you need a lot of data. There is some value in the diversity of web slop out there, but what you do want to finish and anneal with higher quality data sets. You want that to be top of mind at the end. But yeah, the high quality data sets, there's just not nearly enough of it to support a 132 billion parameter model.
So it's both high quality and a large volume of data.
Yeah, I mean, I don't think the comp and crawl dumps are terrible. Yeah, you can be pretty picky and choosy and get some decent results out of it. But if you do look at your average page from Common Crawl, it's like, you know, web forum messages. It's not a research paper. Yeah, there's a place for both. Good questions.
Yeah, good questions. I think, oh, go ahead.
When do you draw a line and say it's fine-tuning versus like curriculum learning? Like it's still pre-training because like are you using this finalized high-quality data on all the layers or you're like fine-tuning to some extent? Or
So maybe the question is, what's the difference between continued pre-training and fine-tuning? They're all kind of continuing training, aren't they? I don't have a great definition other than it feels like people say continued pre-training when they finish the really basic layer of training and finish the training, the pre-training on specific data mixes. Fine-tuning feels like that refers to potentially stuff like LoRa, where you're not even training the whole model, just fine-tuning some adapters on top, or maybe adapting an existing model for existing behaviors. But yeah, in some sense, they're the same.
so this is still like training, pre-training, which is like all layers are being trained.
Yes, this is the whole thing's, there's no LoRa here, for example, if that helps clarify.
Can I say that for fine-tuning, we usually use path to train only a partial of the total architecture parameters. And then there's another part of fine-tuning, something like instruction fine-tuning. It's using specific data sets to tune the model that it can behave for a specific task, like answering questions or like math or reasoning. So you will have your instruction data. So instruction fine-tuning is like one specific type of fine-tuning to prepare the instruction data sets.
Yeah, so the general answer would be pre-training is self-supervised, where you're not doing any kind of labeling, and then fine-tuning you'd be having labeled outputs where you are optimizing for a specific objective. So the way, at least I read the slide, and correct me if I'm wrong, is that when they're doing curriculum learning, you're giving it different subsets of the data or different emphases of the mixture of the data. So you might have more mathematical examples, or you might have more basic science examples before you go to the advanced science examples. But you're still doing self-supervised as a target in that bullet point, right? You're just predicting the next word. You just didn't show it, or you did show it certain pieces of data. And this would still be preceding the fine-tuning stage.
So most corporations have large data sets. Could they theoretically take like this model as an example where it's like pre-trained and then have their large data sets and give that as like a fine-tuning with like these
Absolutely. You usually will have better performance if you fine-tune off a model that was only pre-trained, and then you can do specific optimizations to have better performance on specific tasks. So then you could do instruct training, you could do RLHF, whatever you want. You could do fine-tuning for specific objectives with SFT. But yeah, you can take just the completion model, which is just a pre-trained model. So it's just doing autocomplete as a starting base to do fine-tuning on top of. Because it's a more general, ball of dough, and you can turn it into bread, you can turn it into a pizza, right?
Yeah, just one quick comment here. We actually have a lot of customers doing fine-tuning right now with the Databricks platform. So the whole goal is to have you leverage your own data and build something you have control over.
Yeah,
do you want to repeat the question?
Yeah, what is curriculum learning here? Is it just changing data mixes? Yes, is the short answer. You're changing the emphasis of the data mix. You're right, that's a good definition. This is still self-supervised, unsupervised in some sense. You're just teaching it text. And you're gonna emphasize higher quality data sets, probably. In general terms, that's things like, Wikipedia is nicer than the average Common Crawl page. Math papers are more useful than your average forum post. You can see how that would contribute to being good at reasoning and things like that. So you would simply emphasize those in the training mix more over time.
So the term curriculum comes from like teaching children in school.
Yeah.
You don't start with calculus. You start with basic arithmetic and you work your way up. So the idea is that you give the ML model more general, sometimes noisier, more broad cases to learn from, and then you can hone in on very specific high quality examples as the training progresses, as you've had a lot of grading updates along the way.
So it sounds more like training to be good at MMLU, ML, your math and like graduate, like all the events basically. Is that the target there?
So are we continuing pre-training, doing curriculum learning to optimize metrics? Yeah, in a word. I mean, people care about metrics, even though they're all kind of wrong, but some are useful, right? And a lot of, especially things like MMLU, rely heavily on reasoning. And it's interesting what kinds of data sets help reasoning. It's not just logic problems, it's code and things like that. But there's a lot of metrics. We could talk all day about how can you even say this is good or bad at something and what matters. But.
Yeah, I was just curious about more so the evaluation framework that you decided to use, because there are a lot of instances where, potentially model gets like high benchmark performance, but when you actually, when you actually like optimize it for or try to use it for like chat application or something, like the benchmark the performance doesn't necessarily translate into a nice user experience and something that you expect. So obviously you need to pair that somehow with some sort of, either GPT-4 evaluation or human evaluation. And I guess my question is like, how do you go about, or like what are some general recommendations that you go about selecting that particular evaluation set to see, hey, if I take my model and I generate these completions versus whatever my baseline is, like I can actually see some effect, I guess.
So generally, how do you evaluate models? How do you pick a metric? How do you run the evaluations?
Yeah, I guess it's like how much should you trust like a benchmark result versus like, oh, do I just use the model and just get a qualitative feel for, oh, like this model's good on this domain, bad on this domain, like etc.
Yeah, I mean, I wish I had our eval team here. Evals are hard. Even if you had you knew the eval was what you were looking for, it's sometimes not even clear how to apply the eval correctly. We've had arguments internally, we've had arguments with other people evaluating models about how the correct way to evaluate some results even. And there's not one, right? There's hundreds. Within Mosaic, within Databricks, one of the nice pieces of the open source software stack is a thing called the Gauntlet. And it's just an implementation of tons of evals that you can run on your LLM. And it's all the same, all the common stuff, MMLU, HelloSwag, et cetera. So one nice thing is we can just go compute everything and you can figure out what's meaningful to you. But even internally, I know we've struggled sometimes to figure out what the right eval number was for a certain model because it depends on the prompting. It depends on the settings. Mm-hmm. And it wasn't clear sometimes for this number, how did they generate that? With what settings and what prompting and so on. So maybe to close out, I mean, the only real way to evaluate it is indeed to evaluate it for your use case. Even that's hard to define. Yeah, I think human eval is important too. If you guys have seen LMSys, the chat LMSys leaderboard, that's an interesting place. I mean, that's just random people just typing random questions, but at least it's humans evaluating. And actually, I'll be honest, DBRX in its current version doesn't do as well as we thought on LMSys, even though it does great on MMLU. So it kind of says, it's interesting how these things behave in real life. Wait.
Okay.
Just to follow up on the eval-related questions, at what point in time, and how does this relate to your training or fine-tuning? In other words, I could see that you could essentially almost do effectively reinforcement learning to do really well on a benchmark if it comes in too early, because you start to learn, this is what I need to do, and this is what, if I do these sorts of things, it's going to work better on this benchmark.
on the other hand, if you do it too late, you know, then you may not catch some things. So can you talk a little bit at what stage, you know, that interplays relative to training? Is it completely way at the end and then you evaluate it, or is it somewhere along the way, or does it interplay is even part of training or fine tuning? Talk a little bit more about the relationship of these evals along with the process of sort of finalizing that model with various fine tuning. Sure. So the question is, do you evaluate as you go, or just once at the end? And does that introduce the possibility of you know, overfitting or teaching to the test or something? Yes, we definitely evaluate as we go. So we definitely generate plots to see how these metrics progress over training, because that's an important signal. Like, are we doing well? In some cases, we were actually doing a little bit of research from checkpoints as we went to see what would help and hurt certain metrics to help influence how we proceeded with the training, you know, a day or two later. Does it introduce a bias? Yeah, I mean, there's a danger in chasing, say, any particular metric. And in fact, with commonly used metrics like MMLU, well, at this point, this data set, the questions and answers are out there on the web all over. And even if you're trying to avoid it, it's hard to avoid some copy of that data getting into your training set. And models do, to greater or lesser extent, overfit on things like MMLU, and you have to be careful how you evaluate that. But yes, we evaluate as we go. Yes, we were prioritizing certain metrics. We wanted us to be good at coding and reasoning. I don't think that's a bad thing.
So have y'all looked into doing contamination studies of the training data against the eval data? So as long as you don't have it train and produce gradients against that data, it's not really going to learn from it. So you can always do the eval along the way or after, as long as you've done the contamination study. It shouldn't make an impact on the outcome. Ramon?
Yeah, so some days ago, Microsoft released 5T or 5T, and they, when they were training, I think it was 3 billion, 4 billion, something small, but they made a training that was focused on understanding and logic reasoning, and they forgot about, you know, facts or history or having a lot of knowledge. And it seems that it worked quite well. At the end, if you understand what I'm asking, then I can retrieve whatever fact that I need to answer the question. So that worked very well in a small model. Can you just make that bigger? So can you reach GPT-4 level with a model that is focused on understanding and reasoning of just 20 billion or 30 billion and have the same performance of a model like yours that it's so big? Is it feasible, or what pilot we did, it just worked because it's small?
If I may rephrase our question. So Ramon is asking, it was a Phi 3 model. There's only a few billion parameters. And it was just really great at reasoning, but it couldn't do recall. It couldn't remember anything. It was able to use RAG to fill up that deficit. And with the superior reasoning ability, was having really good performance. That's what you're saying. And you're asking if they can use this.
Since they went for a very big model, can you achieve top performance with the smallest model, and they just reason very well, and they just retrieve whatever fact they need?
I see.
Let's see, I know what you're asking, and I don't know. That feels like an open research question. In a way, yeah, you don't want to spend parameters memorizing facts, because facts can be looked up. You do want parameters to develop, to spend parameters on logic and reasoning, but those things are intertwined. Like, to understand how the world works logically, you have to know things about the world too. And indeed, it's impressive that Phi 3, with not many parameters, captures a lot of that reasoning capability, even if it lacks a lot of factual basis. That's probably a good direction. That's probably how we make progress. GPT-4 is massive. That's still basically a brute force model. MOEs somewhere in between, maybe. But I agree the general trend is we probably want to push more to RAG and retrieval and let the language model do the language and the logic part.
Okay, I think we can proceed
Sure.
with slides, and then I'll go over the Slido questions. I didn't forget about y'all. There's some good questions there, and we can do that after.
Yeah, sure. Those are all great questions. To just provide a little bit more detail or context on the DBRX evaluation, this slide is trying to explain how we evaluate DBRX. But in the practical world, like benchmark performance does not equal your use case performance. You always want to test it on your own data. I've heard people doing this vibe checking thing just to test it out with like a common set of questions they ask for all kind of LLM, just get a vibe feeling of how this LLM is performing. So let me come back to where we left off. I think all those questions actually is a great segue to the slide just to highlight the importance of high quality data. And Zhang also call out that it's not just quality, it's also like the big volume of data. And getting to more details about DBRX architecture, it's using fine-grained sparse mix of experts model architecture. This is mixture of experts are also used in the mixture models. This is like different comparing to like those dense models. In the inference stage, it will select like a subset of experts, and then that makes the inference faster with the same number of with models of the same number of parameters. The model itself have in total 132 billion parameters and supports maximum context length of 32K tokens. So it has 132 billion total parameters, but at the inference stage, because of the mix of expert architecture, only 36 billion of them are used for each like forward pass during the inference process. And it is a dropless implementation. If you guys are interested in learning more details about the model architecture, I would strongly recommend you guys to check out the research paper about Megablock. I have like a link later we can share. And this model is designed for use by enterprises in enterprise settings so that it can accommodate like large volume of proprietary data. All right, comparing, so we mentioned that this is mixture of experts architecture, but comparing with other existing mixture of expert models, here are what differentiates DBRX. It uses more smaller experts comparing with less larger experts. So DBRX uses 16 experts, and it dynamically chooses 4 of those 16. So with this combination, it provides 65 times more possibility in terms of expert combinations. That's where one part of the performance gain come from. And it uses techniques including like rotary position embeddings, gated linear units, and also grouped query attention. I don't remember or recall the details of those, but again, feel free to check out the Megablock paper to dive into the details. So one thing we want to call out is that it actually uses GPT-4 tokenizer. The data we use for training is primarily English, but because the tokenizer is multi-language, so it can still respond to different language queries.
So someone in Slido asked, use the same tokenizer as GPT-4. What other tokenizers were considered before deciding on this one?
Sean?
What other tokenizers were considered?
Or why was this decided on? Yeah, either way.
The alternatives would have been probably GPT-2's tokenizer and Llama's Llama 2's tokenizer. I don't recall if there was a strong reason to pick tick token. It's a pretty broad, has a pretty broad vocabulary, and it's pretty modern. I mean, it does all the normal tokenizer things, so I think it's probably not going to make that much of a difference. I feel like there's some subtleties to tick token that make it a good choice that I've kind of forgotten, like how it encodes numbers, for example. That was before my time, so I plead a little bit of ignorance, but yeah.
You had mentioned that you used the rotary position embeddings. Did you guys consider expanding the context length using long rope?
Did we consider expanding using what, sorry?
So with long rope, you can ingest a bigger context using the same positionings that you did during the pre-training. Have you considered doing that?
Sorry, I don't think I can hear the question.
No, okay. Can we extend the context link further with rope? Yeah, you could.
Yeah.
Well, because you used rope, I was curious if you had considered doing the long rope. I don't think it's technically called training, but you adjust the rotational positions you're generating so that the context that you can ingest, you can increase it up to like 32 times.
This is not my department. From what I remember, yes, you can do that. Yes, people did that. It didn't seem to work nearly as well as it seemed. Unless you train it with a much longer sequence length, it doesn't, just putting in longer sequences doesn't necessarily work so well. But yeah, I mean, you can make this 1 million tokens without too much trouble. Whether it works, different story. But it was trained with 32K, for sure. This is before Mamba. Was it Mamba I heard, or?
Longer.
Oh, long rope, sorry, yeah, yes. Oh yeah, this plane took off in start of the year. It took 3 months to train, so you're on the clock, you know. Yeah.
All right, I'll move on. I think I'll skip those slides. Those are just quotes from tweets emphasizing like quality data.
There was an answer there about the tokenizer, I think. I skipped.
Oh, we have a tokenizer primer in the backup
okay.
slides.
There was a comment on why we didn't use GPT Neox.
All right, now let's talk about tools we use to build DBRX. This is built by Mosaic AI research team with contributions from many other teams across Databricks and also the wider AI community. The main tools are listed here. Composer is the open source deep learning training library optimized for scalability and usability. This is the key training library we use, and for the data ingestion, it is using streaming data set. It's also open source PyTorch data loader, and Databricks LLM Foundry is highly efficient open source code base for training and fine-tuning and evaluating LLMs. For the evaluation, it's using the Gauntlet library from Mosaic. Throughout the process, with that large volume of data, you also need to do a lot of data processing before feeding into the model. And also orchestrating all the jobs and being able to manage all the evaluation workloads. So we use a lot of the in-house tools to build DBRX, those in-house tools including Lilac for data exploration and data curation. And we do everything on the Databricks platform, so leveraging the notebooks within the Databricks workspace, and Unity Catalog is the unified governance for data across different environments. Also, the Mosaic multi-cloud training platform is used to train the model, and for model tracing, logging, and metrics visualization, it is using MLflow and Lakeview. All those tools are available on Databricks platform and is available for other users and customers to repeat or replicate the process, build their own LLMs. So this is the paper I have been mentioning. Megablog is the basis of the mixture of model implementation. And for the distributed training, DBRX used PyTorch FSDP. And at the inference side, it also uses NVIDIA Tensor RT-LLM. And if for folks who are not familiar with Databricks product, we have a product called Foundation Model API, where we host foundation models on the platform, and you can just call the endpoint to interact with different open source model without the hassle of hosting your own models. And for that foundation model API, it is using Tensor RT-LLM in the backend to do the optimization for online inference. VLM is also used for hosted inference at Databricks platform, and we have got a lot of help from the wider AI community, including the AI, is AI 2 or A12?
AI2, it's the Allen
Yeah,
Institute
AI
for
2,
AI.
right? Yeah, it's AI 2, yeah. All right, key lessons learned from like how we built DBRX is DBRX shows us SOTA open source model performance. Of course, that's like back when the model is published on top of the platform. So the key is the data intelligence platform to be able to ingest data, processing data, and use data to train models. So using your own data, you can build your own data intelligence center with like LLM capabilities. And also Databricks is the platform that lets you go from data ingestion to processing and then to all kinds of GenAI applications from RAG implementations or pre-training or fine-tuning. All right, this comes the exciting part. How can you try DBRX? If you guys have your laptop handy, maybe you can like start trying it out right now. You can access it from Hugging Face Databricks Space. If you have been using Databricks Workspace, it is very easy to get access from the Databricks AI Playground. And then the other two sources are like u.com and Perplexity. If you're a Perplexity user, you can choose to choose the DBRX model as your LLM. We have coworkers who have developed examples that allow you to run DBRX locally as well. That can be either from C++ program or using a quantized version on your local laptop. So this is one example showing how to access it from Hugging Face Databricks Space. So this will be how the UI looks like, and you just interact with the model by asking questions through the UI. And this is a Databricks Workspace UI, and you can see on the page left side panel, it has like an AI playground. This is what we were trying to show at the beginning. It actually gives you choices of model comparison side by side, so you can actually click this plus sign here and open up a few more panels or tabs of different model choices. And then you can choose from the foundation model we host in the workspace. Besides DBRX, we also host Llama 3, Mistra, and embedding models like BGE, Large English. And this is the u.com. When you get to like u.com, you can choose model types, and then similar to like Perplexity Labs, in the Perplexity Lab Playground, it gives you like choices to select your model using DBRX Instruct. This all provides like a way to test out the model, get a vibe feeling of it, and just try it out. Right. I think here is like one example. This is actually like a screen capture as well, so it looks static right now, but basically it's just a quick example showing how do you query DBRX using Llama C++. All right, I think I'm going to pause here before I get to summary page.
Sure. So we can go through some of the Slido questions. What are the RAM requirements for the base LLM?
RAM require.
Yeah, memory.
Yeah, I guess it's going to be like anything else. If 132 billion parameters in 16-bit is, what is that, 264 gigs? Yeah, 264 gigs. In 4-bit, more like, what is that? Half that. So a lot. His MOEs are still really big, even if they're surprisingly fast at runtime.
Dana? So Dan asked if the GPU configuration held them back while they were training.
Like, is the hardware a problem? Oh. I see. I mean, certainly we were resource and money bound. We weren't going to spend $1 billion on this one. We don't have $1 billion. So yeah, I mean, if you'd had more hardware, sure. So I mean, within that budget, that kind of determined the parameters, how long we could train and what's optimal. There was 8100s enough though? Yeah, 8100s or 80 gig H100s are pretty good for training. There was a lot of problems with the hardware. A really surprising amount of stuff goes wrong. Orders of magnitude more stuff goes wrong with the networking and the GPUs than you'd imagine. I don't know why. So it was a huge pain.
Piggyback on that again, is DBRX the largest model architecture we tried, or we have actually tried like even larger models, but then due to some like bottlenecks or pain points, we decided to like freeze it with this version?
I think this is definitely the one and only big model attempted by Mosaic.
Gotcha.
For sure. There was a smaller one. We did a smaller one we didn't release, but
Wondering, because you know, I guess I'm one of the using like 3,000 GPUs, and you know, like and for like 3 months or something. But like before you pull the trigger for something, so you commit to something that's going to be so expensive and so hard. Like, what's your process for validating sort of, oh, do I have the right data? Am I doing the right parameters? Is this the right like scale expert things? Right. It's like, you know, like what's your process for then determining, okay, this is, we have confidence that this is like a good idea, then we're gonna go forward with it. And also maybe the secondary question, like, does it happen for you to like try something like thinking, oh, this is gonna be the full thing, but like one weekend you're like, oops, this was bad, like let's kind of year start again.
yeah, I mean, the cost of DBRX was over $10 million. So you're not going to, you want to get it right. If you got one shot at it. So how do you make sure you get it right? Number one, you definitely test beforehand. Ideas, data sets, et cetera, data mixes at much smaller scale. So yeah, we do stuff all the time at the scale of 32 GPUs to see if it works at 1B scale, 3B scale. The problem is sometimes things that work at 3B or don't work at 3B work or don't work at 132 billion parameters. You read research papers, of course, and experiment as you go. To some degree, this was pieced together as it was going because new stuff was coming to light every month during the training. You have evals that help you guide your decisions. And in a lot of cases, should we do this? Should we do that? Let's take a step or two in this direction and that direction and see what's promising. And there's a lot of, take your best guess and just go.
I would say most companies nowadays does not have that huge a budget to train that large of model architecture, but the experience is somewhat transferable, not completely transferable, but somewhat transferable. So you can train maybe smaller models from scratch, and then if you wanted to fine tuning, that's much cheaper than pre-training. So once you have a powerful opened large base model, then you can start like fine tuning process.
Maybe another comment, if I may, just really quickly. I mean, obviously, we come out with this model on 3,000 H100s, and what happens 3 weeks later, Meta comes out. They have 30,000 of them with Llama 3, which is probably a better model than just about everything in open source. So I don't think the point is that customers should be doing this because Meta's and whatever's going to have way more budget anyway. But you could continue pre-training or fine-tuning for way less than that amount of money. But the same infrastructure, same ideas would still apply.
Sean, could you take that?
Let's see, red teaming. I think one thing we're saying I don't think there's any alignment on the base model for DBRX. Definitely there isn't for instruct. I didn't work on that part. I don't know. Well, I have some basic guesses.
During training, do all nodes have a copy of the
It's sharded for sure. Yeah, that's what the
FSDP.
well, yeah, that's what streaming is about too. Streaming's a lot of people have little libraries for like efficiently sharding and downloading data. It's open source, so no, you can go run it yourself. It's Llama style license, so it's free unless you're Google, basically. Have only over 700 million users or something. So yeah, you can use it however you like, really. Yes, yes. So we provide this and other open source models as like pay per token. And our business is more about helping you train and serve your own model privately as well. But yeah, we do that for open source models. And so do some other companies too, yeah. That part, I gotta admit, I didn't work on that. I don't know the details of how we did the instruction tuning. That was a different team.
Is Dolly a good example of instruction fine-tuning data sets?
Yeah, I don't know if we use that data set, but
Right,
things
but
like
that
that.
was a good example, right?
Yeah, that's a good example of the instruction tuning for sure. The like alignment. I mean, I know in our product we use Llama Guard. We offer Llama Guard.
Uh-huh.
I don't think that's quite what went into the alignment tuning for instruct though.
Anthropic human is this data set Anthropic's alignment
Might have been, yeah. That's just not my department.
Yeah, go ahead.
So it seems like a lot of the efforts that you talked about is a lot more in the pre-training phase. So how much of the efforts were spent in SFT and how much was spent in the, you would say the like alignment or the human preference optimization or AI-based preference, something like what Rocket does with Constitution AI?
So how much was the training and how much was the like alignment tuning at the end?
Yeah, so how much of like this was SFT and then how much of this was alignment training?
The overwhelming majority of the time was just the training, the pre-training and curriculum learning. As I recall, the alignment stuff was like the last 10, no, not quite 10%. It's an order of magnitude more was the training than the alignment tuning at the end. That part I just didn't work on, so I just don't know. I don't have much. Yeah.
There was a question over there. The question is about instruct, how to use instruct models.
Yeah, I think it's the same answer for any LLM, instruction tuned LLM. They're tuned to follow directions. I'm going to ask you a question, you give me an answer. Please write me this code. Please go look up this information and give me a JSON document back. That's the instruct part. Use it. You typically consume it as an API because it's hard and expensive to run, and it's probably easiest just to go call GPT-4 or this hosted on Databricks. And then the hard work is really how do I ask it in the right way to get the right answer out? Prompt engineering and so on. That's a whole nother talk, I think, probably. But yeah, it's an API you call and ask questions, tell it what you want it done.
I can provide a little bit more context on the difference between base and instruct. So base is basically just text completion. What it does is just complete your sentences. But instruct is following instructions. Your instruction is just your prompts. That includes both system prompt and user prompt. So the same way you would interact with any like instruction following LLMs.
End users wouldn't use base. That's like the raw materials if you want to keep training.
Yeah, go ahead.
Have you guys looked at what the expert activation distribution looks like? Are there like certain experts that like never get activated or always activated?
The question, I'll repeat the question and Sean, you can answer that. The question is about through the mixture of expert architecture, does we look at the distribution of expert activation? Will there be, or was there any expert that never get activated through the training process?
I remember people talking about this question. I don't remember, I feel like they did something to mitigate that. I don't remember the details. I'm more on the data end of things, less the training. But that's an issue, yeah. It can be an issue because you don't want to overload one expert. Yeah. Yeah. Yeah, I'm pretty sure Mega Blocks will do that. Yeah. Yeah. There's no shared expert in DBRX. Yeah, that much I know.
So I'm new to LLMs. This is my first kind of meetup for this kind of thing. The RAM requirement for DBRX you said was 264 gig RAM at the bare minimum. I remember earlier when you were answering the question, you said there was something lower that you didn't release. Would that have been more public, similar to how GPT 3.5 is widely available compared to something that's less available just because of some of the RAM requirements or the MAL requirements?
So yeah, that's the RAM requirement to load in 16-bit, which is kind of like, feels like full precision these days, even though it's half precision, right? You can load quantized versions down to 4-bit. That would be much smaller, and that evidently fits on a large MacBook. Whether it works well, I don't know at that resolution. So RAM requirements depends on how much you quantize. What I was referring to, as a warm-up, we trained a much smaller MOE that just never got released. It was more of a warm-up. But, you know, I'm not promising anything, but there's much more one can do. Once you have a big MOE, it's actually easier to go the other way, to distill a small MOE from it. So, you know, maybe we can do that too.
For smaller MOEs, is it either to choose smaller expert but still have like more? Okay. No, cool. I think this is a great round of questions.
Okay, so it's 8:12 right now, 8:12 p.m. You're welcome to mingle here amongst each other, a lot of bright minds, until 8:50 p.m. And then after 8:50, we'll walk over, not even a block away, to Higbee's. If you parked, you want to get your car out before 10. So, and we're not the only group in town. AITX actually compiles a list and has a newsletter of the other meetups in town as well. So we're happy to be part of their community. So feel free to take a snap of this QR code and join that. I'll give you a second. Great. Does anyone want to make any announcements? Eric, Jason, Sanat? No? Okay. So yeah, this is Austin Deep Learning. For all the newcomers, welcome. You're always welcome to come back. So it's mostly focused around both the audience and the presenters tend to be researchers, whether in academia or in a company or in a startup. We really like to dig deep, as you saw today. And thank you, Capital Factory, for always being a great host. And don't forget to get your parking validation if you parked in the garage on the way out. So thank you, everyone.
So